Any from here? Lesson 3? They all went good? So if I recall, lesson 3, like the lesson, it started out kind of confusing at first, and then partway through I saw most of you like, I get it. Yeah. Can I do 8? Love to. Okay. Number 8 is a nice twist because it's going backwards. All right. Luke, number 8 is saying, okay, here's my original graph. It's been transformed to that. Now, what does y minus 3 mean? 3 what? Up. And what does x minus 1 mean? Now, this point here is on the new graph. This point here is where we ended up after we went 3 up and 1 right. What point was on the original graph? So here's my new point. But this time they're asking us to go back to where we started from. So if we went 3 up and we ended up at 4, how high did we start from? Yep. And if we went 1 right and ended up at -2, right? D. That makes sense? I like that. Nice twist. Instead of saying go forwards, go backwards. That's always, on any topic I show you, fair game. I can either give you the question, Martin, and say find the answer, or I can give you the answer and say, hey, what was the original question? Right? You've been doing that for years in math. We always do that. Is that it for that one? Okay, let's go to lesson 4. Which was going to be around page 22, I think was the homework. 21. Any here that you want me to do? Now is your chance to ask. It all went pretty good. Well, then let's continue on with the same theme. You know what 2 words, Steph, are going to dominate this lesson? Everything's backwards. Yep. What we're going to look at today, lesson 5, if you'd be so kind. Reflections. I fibbed. My backwards analogy has to be stretched a little bit. But again, today is going to be mostly review, and I'm going to show you one new thing, Blaine, and you're going to say, you know what, that makes sense, because it works the same way stuff did from last year. Reflections, that's the fancy word, Martin, for flips. Okay? And the first thing we're going to ask is, we're going to compare the graph of f of x and y equals negative f of x, except I'm going to write some information down here. I'm going to say this is actually what you get when you replace y with negative y. Remember I said we were going to talk about replacements, Steph, quite often? Now, if you replace y with negative y in this equation, Steph, you'll get this. Negative y equals f of x. Can you see all they've done is they've divided both sides by -1 to move the negative over to this side? But this here is really that replacement. So what I'm going to start talking about, Blaine, is I'm going to ask, hey, what happens when you replace y with negative y? Although this one, technically, you already know the answer. Hey, what happened to the parabola when you put a negative in front of it? Vertical or horizontal? When you flip it, was it a vertical flip or a horizontal flip? Okay, vertical flip. And Chelsea, that's why I wanted to emphasize that it's a y replacement, because I'm hammering the fact that if you're mucking around with the y, it's always going to be vertical. That part of things is not backwards. Okay? So it says this. The graph of at y equals f of x equals x squared minus 10x plus 25 is shown. Write an equation which represents negative that function, the opposite of that function, or Madeline replacing y with negative y. What would the equation look like? Well, the equation would look like this. Y equals negative that function although Sally, they'd probably distribute the negative. They'd probably write it like this. Negative x squared plus 10x minus 25. It says use a graphing calculator to sketch it. We're not going to. We're going to recognize that this is going to be a reflection. Instead of going 1 over 1 up from the vertex, it's going to go 1 over 1 down from the vertex, 1 over 1 down from the vertex. Remember my key points for the parabola? They were 1, 1, 2, 4, 2 squared 4, 3, 9, and then if I can fit 416 on and 525, I will, but I doubt it. Go back to the vertex, 2 over, 1, 2, 3, 4 up, down, 2 over, 1, 2, 3, 4, down. Three over, 9 down, 3 over, 9 down. Put your pencils down. I'm going to show you a different way to think about this. Look up. When you replace y with negative y, Luke, you're doing a vertical reflection. What's happening is your x's don't change, but all of your heights become the opposite. Hannah, right here, how high am I right there? It's a trick question. 0. What's the opposite of 0? Still. We have a fancy word for that. We call that invariant. We say that's an invariant point. Right here, how high am I, Hannah? 1. You know what it's going to become? Negative 1 high. The x value stays the same, but the height becomes the opposite, because we're taking negative y. This point right here, how high is it? What's it going to become? Negative 4. This point 4 high is going to become negative 4 high. By the way, Hannah, this point to the left, which is 1 high, is going to become negative 1 high. This point over here, which is 4 high, is going to become negative 4 high. And then I think there's a 3 over 1, 2, 3, 4, 5, 6, 7, 8. Yeah, right here is 9 high, and it's going to become negative 9 high and negative 9 high. This is going to be, and now you can pick your pencils up again, this is going to be a vertical reflection. It said use a graphing calculator. We just did it. State the coordinates of the invariant points. Oh, you know what? There's our definition. Why don't I highlight that? Why don't you underline it? An invariant point is a point that stays where it is. And in English, those of you that speak English as your first language, the word invariant kind of makes sense. The way it's invariant does not vary. It doesn't change. Okay, so it says state the coordinates of the invariant point. 5, 0. Everything else moved. Okay. Part 2. Here is a cubic graph. This is a cubic that's been moved 8 down, but this is my f of x, and they want us to write the equation that represents that there. Okay. That would look like this. Y equals negative the original equation. When you write y equals negative f of x, you're replacing y with negative y. What you're really doing is you're saying make the equation its opposite. Is that okay, Justin? Although, Justin, we would probably distribute and write this as negative x cubed plus 8, for what it's worth. But they gave me the graph. Replacing y with negative y, or doing this transformation, this is going to give me a vertical reflection. Add x to the 8th, thank you. Candy for you later, Luke. Thank you. My bad. But Luke, here's what's going to happen then. Every single height is going to become its opposite. For example, Luke, right here on the y-intercept, how high is that? You know what it's going to become? Yep. And just to the left of the y-intercept, this looks like it's negative 1 comma 9 down. It's going to become negative 1 comma 9 what? Up. It is backwards, miss. Yeah. Let's get, well, I'm looking here. Justin, that's a nice point right there. Just 1 to the right of the y-intercept. This looks like 1 comma negative 7. What's that going to become? How high am I right here? So what's going to become? Yep. Let's try and find another nice point. Oh, you know what? I think right there, I think this is 2 comma 0. What's going to happen to 2 comma 0? It's going to stay 2 comma 0. In fact, I think the new graph is going to look something sorta, kinda like that. How come you're late? Oh. Really? Did I sign it? Okay. I don't remember. It says state the coordinate of the invariant points. 2 comma 0. Okay? And then it says, how does the graph of y equals negative f of x compare with y equals f of x? Here's the fancy terminology. It's a vertical reflection about the x-axis. It's a vertical reflection about the x-axis. Don't you mean the y-axis vertical? No, no, the x-axis. Here's what we're saying, Martin. If you could hold your thumbs on either end of the x-axis and spin it, that's what you're doing to the piece of paper. You're spinning it around the x-axis. Okay? So, now let's do some generic ones. Ready, Blaine? Here's f of x. Sketch that. Every height is going to become its opposite. When I'm doing this, usually I do the invariant points first. Which points will be invariant? Anywhere that's how high? You know what? That's not going anywhere. That's not going anywhere. Gives me a reference right away. Sally, this point right here to the left of this invariant point, how high is it originally? This point right here to the left of the invariant point, how high is it originally? Negative 1, how high will it become? This one's 0. Oh, and they're connected. Hey, this point right here to the right, 1 to the right of the invariant point, how high is it originally? Give me a second. View. Let's try this again. Drop. This point right here, 1 to the right of this invariant point, this guy right here, how high is it? How high will it become under this transformation then? Yep, and connect them. Hey, Sally, how about right here? How high will it become? In fact, I think that arm is going to become that. Steph, how high is this point right here? The y-intercept. 1. It's going to become negative 1. And it's going to go through that. You know what? I've spotted the pattern, haven't I? I think that blue graph is the image of the original reflected about the x-axis. You've spun it around the x-axis. Or if you want to think of it this way, Justin, the x-axis is where you folded the paper in half and creased it, and that caused the top half to go onto the bottom, and the bottom half to go onto the top. Does that make sense? Kind of weird to think that way. Turn the page. Okay. All right, pop quiz. If replacing y with negative y gives you a vertical reflection, what do you think replacing x with negative x gives you? Horizontal reflection. Now, you didn't do that last year. Why not? Here's a parabola. Flip it horizontally. Oh. What's the problem with the parabola? It's symmetrical. Wasn't much fun to flip horizontally, not in standard form. In non-standard form, it's a little bit more interesting. So it says, here's my graph. This is in expanded form. Write an equation which represents that. What this is saying, Chelsea, is replace every x with the negative x. It's going to look like this. Y equals negative x squared minus 10 times negative x plus 25. I'm coming to that. Baby steps. Remember I said we're going to use the replacement method even when it seems easy, so that when they get nasty, we've gotten good at the replacement method. Because I can hear Martin, he's saying to himself, oh, Mr. Dueck, there's a better way to write that, for Pete's sakes. You can simplify, and I agree you can, absolutely. This is going to be y equals, Martin, what's negative x all squared? And what's a minus minus the same as? So these two equations are the same, and they are a result of this transformation. What did you say that replacing x with negative x does? What type of a reflection? Horizontal. In other words, Sally, exactly the same thing is going to happen as I did to you one question ago, but instead of me saying how high, I'm going to say how far left, right, and those are going to become the opposite. Are you ready? Here we go. We're going to do this point right here, the vertex. How far right is it? Positive 5. You know what it's going to become? Negative 5. The height doesn't change, though. And let's do the point 1 to the right of it, the one that's 1 over 1 up. It's 6, comma 1. You know what it's going to become, Sally? Negative 6, comma 1. Right there. Yes, Hannah, everything's backwards. Oh, let's do the point 1 to the left, which looks like, Hannah, 4, comma 1. You know what it's going to become? Negative 4, comma 1. And I could do the rest, but I'm just going to stop there in the interest of time. It's a reflection. By the way, stay on this page. Did you notice the pattern between the invariant points? When you did a reflection, which heights vertically didn't change? The x-intercepts, the roots, anything on the x-axis. What about horizontally? Which left-rights won't change? Okay, I'm just going to write where it says state the coordinates of the invariant points. The y-intercepts will stay where they are. I don't feel like calculating it. Oh, I can figure it out, because how do you find the y-intercept? Put a 0 in for x. You put a 0 there, put a 0 there. The y-intercept is 25. I just don't feel like crunching them. Okay? I'm going to skip this one, and I'm going to jump right down to here then. Steph, can you see in this transformation, there's the before, there's the after, can you see the difference if we've replaced x with negative x? And what that's going to do is all of your lefts are going to become rights, and all of your rights are going to become lefts. All of your x variables are going to become the opposite sign. I'll start with the vertex this time, because that's a really, really handy one. Steph, this vertex, how far left is it? 1. How far right will it become? Just 1 to the right. Same height. So instead of negative 1, comma 2, positive 1, comma 2. Right there. Hey, Steph, what about the y-intercept? Oh, invariant. Because it's 0 left, right. And what's the opposite of 0 left, right? Still 0 left, right. So that's going to stay. What about this point right here? It's 1, comma 0. It's going to become negative 1, comma 0. And you know what? I've spotted the pattern. It looks like one arm is going to do that. Let's do the other arm. Let's take this point right here. Okay? Right now it's negative 2, comma 1. Reflected. Comma 1. Steph, spot the pattern already? I think the other arm is going to do this. Now, once you've drawn that, step back and ask yourself, Is this a reflection? In fact, this is a horizontal reflection about the... But which axis are you spinning this piece of graph paper around this time? Because I asked you to. Which axis are you spinning this piece of graph paper around this time? Why? Because I asked you the y-axis. Absolutely. Okay. Let's generalize. Oh, no, we got one more reflection. Sorry. This one I already did with you. Are yours filled in? Is this one filled in with you guys already? No? Good. What does that symbol mean? Do you remember? Inverse. How do you find an inverse? And remember, they can also sometimes write it like this. Now, this is also a reflection. So if we switch the x and y, instead of 5, 0, what, comma, what? 0, comma, 5. Literally switch the x and y's around. And I find saying them in my mind out loud, you can't say them out loud on a test, but in your mind, like I almost, in my mind, I go, and then I flip it. I'd probably have to give it 0. I'd probably have to reflect your grade in the negative direction. Okay. Martin, this one here is 6, 1, 1, 6. This point here is 4, 1, 1, 4. And now I've started to figure... Oh, missed it, Mr. Dueck. Now I've started to figure out the pattern for this parabola. It's going to go like that. Okay. I want to jump to part 3. Remember, this is also the symbol for inverse. I prefer that symbol, Matt, because to me, oh, look, instead of y equals f of x, it's x equals f of y. Haven't they actually switched the x and y around in the notation? That makes way more sense. They're not going to use it. Almost certainly, they're going to use this. So make sure you know that also, Charles, means inverse. How do I find an inverse, Charles? So let's do the vertex first. Instead of -1, +2, what's it going to become? Okay, you're making it too tough. Instead of -1, +2, what's it going to become? +2, -1. Boom, boom. Oh, let's do this point right next to it, the y-intercept. Instead of 0, 1, what's it going to become? This point right here, where I've got a blue dot, Charles, was also on my original graph, so I'll reflect the original point. 2, -1, what's that going to become? 2, -1 is going to become what? 2, -1, -1, 2. In fact, I think I've spotted a bit of a pattern. One arm's going to look like that. Let's go in the other direction. So we started with the vertex, Steph. We went to the right. Let's go to the vertex and go to the left. Steph, this point here is 2, sorry, careful, -2, +1. What's the inverse? +1, negative. Let's try that. 1, -2. Is that looking good? Yeah, you know what? In fact, I think it does this. Hang on, Mr. Dueck, you botched that because you can't draw. I'll do one more point. I'll do this x-intercept, which should become a y-intercept if I switch the x and y around. Let's see, -3, 0, 0, -3. Oh yeah, I was right. That blue graph is the inverse of the black graph, and I'll prove it to you. Do you remember what reflection inverse was around? It was around the line y equals x. If I go like this, if I draw a line going through 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, -1, -1, -2, -2, -3, -3, -3. If I draw that, those are reflections of each other. By the way, So, Hannah, ready? Vertical reflections, the x-axis was an inverse because your heights of 0 stayed 0. Horizontal reflection, the y-axis, Madeline, was an inverse because 0 left right stayed 0 left right. Sorry, it was invariant. Did I say inverse? Was invariant. Was invariant. Stayed where it was. What's invariant on an inverse graph? And Blaine, the answer is anything that's on that dotted line. 1, 1, 2, 2, 3, 3. Anything whose x and y coordinate are already the same, because when you switch them, they just stay the same. If it goes through 5, 5, what's the inverse of 5, 5, Justin? What's the inverse if it goes through 2.32, 2.32? What's the inverse of 2.32, 2.32? In other words, any point on the reflection line is invariant. Turn the page. Ooh, here's another lovely summary page that's worth dog-earing, I think. Okay? Here's a summary of everything that we've done so far today. If you want to reflect in the x-axis, now if you're reflecting in the x-axis, Luke, what that means is you're putting your thumbs on either end of the x-axis and you're spinning your thumbs. That's going to cause the paper to rotate this way, vertically. So I'm going to put in brackets here, vertical reflection. Luke, did I say everything's backwards? So reflecting in the x is a vertical reflection? Yeah. If a graph is reflected in the x-axis, then it's a graph of y equals negative f of x. Nope. Ready? Look up. Here's the x-axis. See how I got my fingers holding the end of it? If I spin my fingers, the paper is going to rotate this way, isn't it? Isn't that a vertical direction? See my x-axis right here? Okay, if I spin it, can you see what's turning? Is this? It's the heights. The bottom became the top, and the top became the bottom. That's backwards. I wasn't kidding, by the way, when I said that beam's going to run through the whole unit. Okay. If you're on the quiz and you're not sure, right. Okay. In other words, Chelsea, if the thin graph is my original, and if I spin it along the x-axis, if I put my two thumbs on the arrows on either end of the x-axis and give the paper a half turn, the thick graph would be the result. This is y equals negative f of x. Okay. What about if we reflect in the y-axis? Now, if I reflect in the y-axis, then Chelsea, we're saying we're holding it here and here and spinning it this way. That's going to cause it to rotate this way. That's horizontal reflection. And I'm going to write that in brackets here. Horizontal reflection. So, if the graph of y equals f of x is reflected in the y-axis, then it's the graph of y equals f of negative x. You're replacing the x with negative x. Like that example, can you see, Hannah, that the thin graph, if you spun it this way horizontally, gives you the thick graph? And the thick graph would be y equals f of negative x. Come on, come on, negative x. And then we have the inverse. Chelsea, ask. It's a good question. No. No. Okay, stay on this page. Stay on this page. Hang on. Stay on that page. Horizontal reflection in which axis? Okay. Vertical reflection in which axis? Then the last one is the reflection in the line y equals x. By the way, we call that the inverse. So if the graph of y equals f of x is reflected in the line y equals x, that's that 45-degree angle line that goes through 1, 1, 2, 2, 3, 3, 4, 4, then it's the graph of x equals f of y, which is the notation I like better. They're not going to use that one. Or they're going to use y equals f, stupid little negative 1 of x, the inverse. Because it's not an exponent, even though it looks like an exponent. They could have easily, pardon me? Oh. Doesn't have the brain power to be stupid? It's a football play. Never mind. Okay. Ooh. Now, can you see how you can tell by glancing at this that this is a reflection about a 45-degree angle line? Okay, it kind of stands out. So this is y equals f little negative 1 of x, or x equals f of y. So Chelsea, here's your summary in English instead of in pictures. If you replace x with negative x, that's a reflection in the y-axis, except I'm going to add one more thing. Are we replacing x or are we replacing y in this statement here, Chelsea? Are we replacing x? No, you're overcomplicating. Yep, say it, read it. So this is a horizontal reflection because it's x. In other words, your lefts are going to become rights, your rights are going to become left. But when you do that, you're spinning about the y-axis to do that. Is that okay? Is it make sense now? Okay. Same thing here. Replace y with negative y. This is a reflection in the y-axis. This is a vertical reflection. In fact, Chelsea, I agree with you, sort of. I find this terminology so confusing. I will always just say horizontal reflection, because I know that means x, or vertical reflection, because I know it means y. But on the test, on the provincial, and in the homework, they will often refer to the axes. So get used to it, but I honestly think they could do better with their terminology. Okay, fine, I agree. A horizontal is about the y-axis, but why don't I just call it a horizontal reflection? It's less writing, it's clearer, it's less confusing. But I'm not in charge. Oh, and then interchanging x and y. Inverse. So let's try some. Next page. Okay. It says the graph of y equals f of x is shown. Sketch. Okay. What is this one here? Vertical or horizontal reflection? So I'm going to write down origin here. Vertical reflection. Now, technically, Hannah, it's a vertical reflection about the x-axis. Chelsea, did I write that about the x-axis phrase? I find that confusing. Vertical, I know my ups will become downs and my downs will become ups. So, ooh, this guy right here, Chelsea, invariant. Right? Because how high is that first point? No, how high is that first point? 0. What's the flipping reflection of 0? Still 0. Negative 4 comma positive 6. What's that going to become? Negative 4, negative 6. 2, 4, 6. Oh, and connect them. Negative 2 comma 6 is going to become what? Negative 2, negative 6. And connect them. By the way, can you kind of tell by looking if you've done it right? These usually end up being fairly symmetrical with each other, right? 0 comma 4 up is going to become 0 comma 4 down. Connect them. What would be the next point I would choose? I think I would pick this x-intercept, because you know why? How high is that x-intercept? 0, so what, invariant. It's got to go right through there. Even if that was a decimal, I would still make sure I went right through there, because it's not going anywhere. Hey, Luke, This point here, what's it going to become? 7 comma, connect them, and then, 9 comma 0, connect them. That red graph is the image of the original reflected about the x-axis. Oh, I don't like that. Vertical reflection. I like that better. B. Okay. Let's do that so you guys can see a little easier. B. F of negative x. What kind of a reflection is this? Going to write down here horizontal reflection. And yes, the x's will become their backwards. Everything's backwards. So instead of negative 5 comma 0, positive 5 comma 0, which I think is right there. And I always go in order so that I can just connect the dots along the way. In other words, Hannah, I wouldn't suddenly jump and do this point. That would be silly. Because you went, "What?" I'm doing this one next. Negative 4 comma positive 6. Positive 4 comma positive 6. And connect them. Negative 2 comma 6. Positive 2 comma 6. And connect them. 0 comma 4 high. The y-intercept will be invariant, won't it? So Kellen, I'll make darn sure I go through there. And then I'll use this x-intercept right here, which I think is 4 comma 0. Negative 4 comma 0. I'll make sure I go through there. 7 comma negative 3. Negative 7 comma negative 3. I'll go right through there. 9 comma 0. Negative 9. 1, 2, 3, 4 comma 0. Is that okay? What's the next one? Inverse. Switch the x and y around. Okay, careful. This is where I see kids make the most sloppy mistakes, by the way, is on inverse. So you ready? Try it on your own. Tidy mine up just a little bit. I got that. Not sure if that's correct or not. You know what I'll do? Luke, I'll do my little cheat. I'll put the line y equals x in there. And I say, yeah, that looks like a reflection about that. Is that okay? Example 2. Says the graph drawn in the thick line is a reflection of the graph drawn in the thin line. Write an equation for each graph drawn in the thin line. Or in the thick line, sorry. Hey, look at those three. Which of those looks like an inverse? Y equals inverse. So look at B and C. Which one is a horizontal reflection? Which one did your lefts become rights and your rights become left? Which one is invariant on the y-axis? Because that's the one that would go, right? Which one goes through the same y-intercepts? Yep. That's a horizontal. You know what the third one is? It's a vertical, and I'll convince you because I notice the x-intercept, the height of 0, is invariant. Y equals negative f of x. Okay? Part 1 of your lesson. Homework number 1. Number 2, number 3. Yeah, 4 is good. Seven. And turn the page, because the next lesson is reflections part 2, and I think it's just going to be more practice and it'll actually be clear. I know I've been talking for a bit, but suck it up, Buttercup. You're good. Oh, another lovely summary there on lesson 6, which is page 33. So, hey, we've just done this. Okay? It says, write the equation of this after a reflection in the line y equals x. Reflection in the line y equals x, is that horizontal, vertical, or inverse? Inverse? How do we find an inverse, boys and girls? X equals y squared. Did they tell me to get the y by itself in part A? I'm not going to bother. I could. I'd square root both sides, plus or minus. B, reflection in the y-axis. Okay, I got to always think, because Chelsea, you're right, it is confusing. The y-axis is this one. So I'm sitting around the y-axis like that. Okay, I kid you not, I do this. You know what? What changed? Horizontals. My lefts became rights, and it is a horizontal reflection. This is what you get when you replace horizontal x with negative x. So you know what the equation would look like? Y equals 10 to the negative x. That would take the exponential graph would look like this, and do that. C, a reflection in the x-axis. Okay, x-axis is this one, and what I literally do is I imagine myself somehow spinning little flips like a gymnast with my arms holding still. That's a vertical reflection, right? Whatever works for you, by the way, to wrap your brain around the terminology, but I know how my brain works. That's replacing y with negative y. I think as an equation, that's going to be y equals negative square root of x. And Blaine, I can tell you what that looks like. It's the wounded seagull, but down there. Right? Without the little curvy part at the end. I drew that kind of sloppy. But I can get this. Describe how these two compare. Horizontal or vertical reflection or inverse? Chelsea, did you say horizontal? Luke, did you say horizontal? Because you're right. Watch. It's both. It's both because of just how math works. Now, I would pick vertical because it's the easiest, but look. If you don't write this down, if you did this, what is a negative times a negative times a negative? In other words, if you simplified that, doesn't it look like that? Now, here's what that's saying. The x cubed graph that one, right? What you're saying is flipping it this way, vertically, see it, is the same as flipping it this way. See it? Right? So both answers are valid. I'd pick the simpler one. I would glance at that and I would vertical. But as it turns out, this has the fancy word, this point symmetry. That's when you can flip a graph horizontally and vertically and you end up with this. You don't need to know that for Math 12, but it is nerdly cool, and I got to do my John Travolta again. Really, Mr. Dueck? Really? Hey, what's this one? Yep, inverse. By the way, where's the y sitting? If I needed to get the y by itself, what would I do to both sides? Log. Okay, it's going to come back to haunt you or thrill you. Here, Luke, this one here definitely horizontal. And you'll notice, Chelsea, I didn't add the about the whatever axis to the, because it does confuse me. Okay. How many more? Yep, we're almost done. Good. Example 3. What's going on here? So if my original is y equals x squared, x equals y squared, and then it adds one more thing. It says state whether the new graph represents a function. Do you remember how you could tell by just glancing at a graph whether it was a function or not? There was a test. Ooh, I heard it. Yes, you're right. The vertical line test. The vertical line test said, okay, please imagine this thin one is gone. I don't want to erase it. I can, but just imagine it's gone. It says if you run a vertical line's shadow along the graph, if that vertical line touches the graph in more than one location at the same time, it's not a function. Am I touching the thick graph in more than one location at the same time? Is it a function? No. Now I can tell you some of the reasons that has profound significance. Your graphing calculators cannot graph non-functions. It can't. Because it doesn't know which y value you want. All it does is it plugs in x values at random, but if there's two possible answers, it doesn't know what to do. It's a limitation of the software. Okay, so I'm going to say that, and I'm going to say not a function, not FNC. Hey, what's going on in B? Horizontal or vertical? I think vertical. So vertical means you're replacing y with negative y. It must look like this. Y equals negative absolute value of x. That thick graph, is that one a function? Now the power of the vertical line test, by the way, Chelsea, is you can almost do it in your head. You can just imagine a little ruler moving along. So you glance at it. Yes. Turn the page. Okay. Niet. Okay. Did you just rip through your page? You were so proud of that being able to cross it out, Luke? Imagine. Example 5. Given that, find the inverse. Okay. How do I find the inverse? Okay, pretend f of x is the same as y. So I'm going to temporarily just put a little y up there to remind myself this is y equals 3x plus 2. So the inverse is going to be x equals 3y plus 2. But this one I can get the y by itself pretty easily. How would I get the y by itself, Matt? Minus 2 and then divide by. So I'm going to say y equals x minus 2 all divided by 3. There's my inverse. What is B asking for? The inverse of the original. What is the third one asking for? The original of the inverse. I'm just going to, because we're running out of time, I'm just going to let you in on the punchline here. If you take an original function, this thing, and you actually substituted that right in for the x, which is what it's saying, wherever there used to be an x in the inverse, put the original function. What you find is everything cancels, and all you're left with is that. All you're left with is that. I don't think you need to know that for Math 12, which is the other reason I kind of glossed over it. Pardon me? I don't think you do. In fact, you know what? I'm going to cross those two out. I just wanted to review finding the inverse of an equation. So, we're done. Oh. 1. Practice writing the equations. These go pretty quick. 2. You're going to say horizontal reflection, vertical reflection, or inverse. So pretty quick answers. 3 is good. Nah, I'm good on 4. 5, little semicircle. What's the radius of that semicircle? Do you remember? 4. So in other words, well, the original graph is going to look like this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So the points you're going to be moving around are -4, 0, +4, 0, 0, 4. And then connect the dots. So 5 is good. Nah. 8 is good. And I'm done. So you got about almost 20 minutes, about 18 minutes to work on the homework. And although it seems like a lot, I think a lot of this is kind of plug and chug, Blaine, fill in the blanks. I apologize, I've done 2 lessons in a row. I used to separate them, but I found, Blaine, powering through it in one day actually solidified the concept more, because I think it was better once you got your brains around it. Let's do some tougher ones right away, okay? I know it's me talking a lot. You got the rest of class. I'm shutting up. Just let me turn off my little recording, and then I'll answer any questions.